Hello everyone, welcome to Module 34, Tolerance of Position or TOP. So far, we have learned a lot about tolerance of position or position tolerance. In this module, we are going to learn, first, review the TOP. The second, what is the tolerance feature of TOP? We are going to explain the difference between ASME and ISO GPS about tolerance feature. Next one, what is zero tolerance with MMC modifier? The last one, projected tolerance. As we said, the position tolerance is the location to one or more feature size is used for feature size. These relate to one another or to one or more datums. Position tolerance could be used to locate FOS relative to each other or relative to the datums. TOP usually is to define the location tolerance of FOS from the true position. What is true position? Theoretically exact location of a FOS as defined by basic dimensions. And we also know we could use the MMC modifier to the TOP, and we could also use the LMC modifier to the TOP. In this case, we used the terminology of surface interpretation, and this surface is remaining to the virtual condition boundary. If there's no MMC or LMC modifier, then it's RFS regardless of feature size. In this case, we explain this axis or center plane interpretation. Because in this case, there's no bonus. The TOP is used to control the tolerance of axis and center plane, and tolerance zone is going to be either cylinder or a two parallel plane. Here is the RFS. We call this axis or center plane interpretation because there's no MMC or LMC modifier. This tolerance zone is used to control the axis. In this case is the axis of the AME of this hole, or could be used to the center plane if the tolerance feature is a slot or is a plate. If there's MMC modifier, in this case, we call this surface interpretation. Because in this situation, we're going to have a virtual condition boundary here. The main purpose is to ensure the virtual condition boundary is guaranteed. That's why we call this surface interpretation. And tolerance zone is not fixed anymore. The tolerance zone will be flexible because of the bonus tolerance. Same thing for LMC. Here, LMC, you're going to have a virtual condition boundary. The virtual condition boundary for this joint is the outer boundary here to guarantee the minimum thickness of these parts, as we explained in the previous module. Now let's talk about when we use the MMC or LMC modifier, we could see sometimes the zero tolerance value with MMC or LMC modifier. Here, let's have a look at this joint. This joint with MMC modifier here, the function of these parts is to ensure we're going to assemble M44 bolt into this hole, and the reference to datum A, B, C. B is here, C is here, with basic dimension. Again, please be reminded, this assembly should be locate parts to A, B, C first. The next, we're going to mount this threaded bolt into the hole at nominal position 2B and 2C. This is the function. We're going to have a look at this function. If the hole size is 4.8, it's the worst situation, minimum hole. In this case, there's no bonus. The position tolerance is 0.4. the 4.4 function is okay for the both. Or we can say the virtual condition boundary is 4.4, which will enable this threaded bolt mounted inside. Same thing for 5.0. The position tolerance is 0.6 because of the bonus, but the function is okay. 4.4 threaded bolt is going to be okay. 5.2, this is the ME size. Position tolerance will be 0.8. The function is still okay. So we should focus here. This is the function that what we want here. This is the function we should pay attention to. What we need is the function okay. We do not need the position tolerance at a fixed value. The position tolerance is not fixed anymore, but the virtual condition boundary is fixed. It's always 4.4. Next, what about the hole size is 4.7 or 4.6? If the hole size is smaller than 4.8, that means it's out of tolerance, right? The minimum is 4.8. If it's 4.7 or 4.6, it's out of tolerance. But there's a possibility the function of this part will be okay. Why? Look at position tolerance. If the position tolerance is 0.2 or less than 0.2, in this case, the virtual condition boundary could be still 4.4, right? That means these parts can be used for assembly. From function point of view, this part is okay. But unfortunately, this part is rejected because the size tolerance is smaller than 4.8. Now we have the questions. If the function is what you want, then this joint has some problem. We don't care the hole size is smaller than 4.8. What we are caring about is the function of these parts should be okay. What's the function? M4.4 should be mounted into the hole reference to A, B, C. This is the function. So there are some waste here. The function is okay, but parts is rejected. Same thing here, 4.5. The position tolerance is 0.1. And it's not okay, right? This is the waste until to 4.4. So we need to change this joint. How to change this joint? In this case, first, we need to change the lower limit of the hole diameter to 4.4. You see here, the lower limit is 4.8. Now we change it to 4.4. In this case, we are going to use 0 tolerance value with MMC modifier here. This is what I'm going to explain here. What is 0M? 0M means if the hole size is 4.4, the tolerance value is 0. Here, 4.4, the tolerance value is 0, right? What about 4.5? If it's 4.5, here, you're going to have a bonus. The position tolerance will be 0.1. It's not 0 anymore. If it's 4.6, the position tolerance will be 0.2. And 4.8, the position tolerance is the same as this joint here. 5.2, according to this joint, position tolerance will be 0.8. So from here to here, they have the same, both joints have the same requirements actually. But this portion is different. This portion is good part according to this joint here. But this was rejected by this joint. So you can see here, we have different amount of qualified parts if we use different join here. But from function point of view, both join has the same function purpose. They all can guarantee that M4.4 could be mounted into the hole reference to B and C at basic dimension. So the function is the same, but qualified path is different. So from this point of view, we would recommend to use this instead of this. And you're going to have more qualified parts. 0M is not equal to 0. 0M is used to increase size range or size tolerance of feature size, and at the same time guarantee the function of these parts. All right. Next, we're going to talk about the tolerance feature. What is tolerance feature? This seems very basic questions. When we have a position tolerance here, the tolerance feature is this hole. But what about this hole produced with deformation here? So what is tolerance feature? As we mentioned, well, it's the AME of this actual hole. Even this hole is deformed, but we're going to construct an AME. What is AME? Maximum inscribed cylinder here. This is the AME. This AME, we're going to have a straight axis here. And this straight axis is the tolerance feature of this position tolerance. The 0.4 tolerance value is used to limit the axis of the AME. So before we measure these parts, we have to construct the AME, and then we get axis. The next, we could evaluate the position of this axis to prove that it's within this tolerance zone. All of this definition is based on ASME Y14.5. This is the definition of ASME. What about ISO GPS? ISO GPS has different definition about tolerance feature according to ISO 17450-3. Let's have a look here. Same join. Position tolerance is point to the hole. What is the tolerance feature? The tolerance feature is a medium line. And you can see a little bit of difference comparing with ASME. This line is not straight. This medium line is a curved line. How could we get this curved line? This is the actual hole is deformed. And once the hole is deformed, we need to find the medium line. The medium line actually is deformed either, or we could understand that first we need to construct a perfect line here. We can just imagine that it's a little complicated according to ISO GPS, but we can experiment a little bit here. First, you're going to construct with the least square method, construct a cylinder here. And then you get the initial axis. Again, this initial axis is not tolerance feature. Next, you're going to cut section here, right? You're going to cut section here. Cut it. Intersection plane for which should be perpendicular to this axis. And then you get a circle, right? And this circle, actually theoretically, this circle you need constructed because each section, the circle could be not be perfect, right? The next, what you're going to do, you're going to construct another line with least square method. Then you get what? You get this center point. Each section you get a center point, and you line it line them up, and then you get this medium line. It's a little bit complicated, but long and short, we should understand that there is a difference between the ISO GPS and ASME. The tolerance feature is different, right? The next questions: if I want to measure the AME, how could you do that? Because from a function point of view, AME is representing the function. So I would like to express how we could use the AME to simulate the function. In this case, we need to change this join. How to change that? You need either symbol X circled here. This symbol means you're going to use the maximum inscribed cylinder as a tolerance feature. So it's going to be the same meaning as ASME if you add this one. So you could see ISO GPS, you need to add some special symbols in order to express that what you need is the ME. Otherwise, the default tolerance feature will be medium line. So this is different. All right. Next one about projected tolerance zone. Let's have a look at this symbol here. Here, there's a small symbol here, P circled. We call this projected tolerance zone, which is widely used for the threaded hole. Let's have a look at one example. What does it mean of this projected tolerance zone? First, when we talk about assembly, there's two situations. Assembly with threaded hole. Situation number one, part A is threaded hole. Part B, it's just a through hole. There's no threaded, right? Just a hole here. Next one, you're going to screw this bolt inside and link these two parts together. In this case, the bolt is fixed to the threaded hole. That's why we call this fixed fastener assembly. Again, one side is threaded hole, another side is the hole without thread. Situation number two, part A and part B, both part is hole without thread. You push the bolt inside and then you put the nut on the bolt and tighten it up. In this situation, the bolt is allowed to float inside the hole. That's why we call this floating fastener assembly. Right? Again, let's come back. What about projected tolerance? Projected tolerance zone is used in this situation. In order to mount these two parts together, we must ensure the bolt won't interfere with the hole, right? How could you ensure the bolt won't interfere with the hole? You need position tolerance. The next one, you're going to put a position tolerance to the threaded hole, or this hole here, this hole here. 0.4 means the position of this threaded hole supposed to be within 0.4, or we'd say the axis of this threaded hole supposed to be within 0.4 tolerance zone. This is the situation here. This is the tolerance zone 0.4, and here is the axis of this threaded hole. And the next one, you're going to put threaded bolt inside, or threaded screw inside. What about if this hole is tilted, but the axis is still within the tolerance? You see here, the threaded hole is tilted, but the axis is still within the tolerance zone. The next is the bolt will be extended because you control the position of this portion, but the bolt is from here to here. This portion, you're going to have the interference with the hole. And the axis from here to here of this bolt will be exceeding the tolerance zone of 0.4. That means you control the position of this portion of the bolt, but this portion is out of control. From function point of view, all you need to control is not this portion. You have to control the position of this portion because this portion we are going to mating with the hole. So how could we do that? This is what we want to control. We want to put this inside tolerance zone. This is not what we want because this portion is the function portion. That's why we're going to put P circle here to representing the tolerance feature is the projected feature. It's a projected portion. The projected length is 10. Let's have a look here. This is the projected portion, and here is the threaded hole. The projected portion of this thread or this bolt should be within the tolerance zone 0.4. You see here? It's within the tolerance zone. So we could control there's no more interference between the bolt and the hole. Right? 10 means the projected length and equal to the maximum thickness of this part. The maximum thickness of this part. Next one, you see here, once we control this portion, then there's no more interference. Right? Projected tolerance zone is widely used for a threaded hole to simulate the extended portion of the bolt. But next question is, how could we measure this? In order to measure the projected tolerance zone, there's two ways. Either you could use CMMs, for example, to simulate the extended portion. This P circled modifier is an option. You can select this option when you calculate this position in CMM. Or next one, you can make a tracking pin. You mount the tracking pin inside and with the extension of 10, then you measure the position tolerance of this extended portion. All right. Here, projected tolerance is usually used to thread the hole or press feed pin. That means the feed pin pushed into the hole, suppose is not floating freely, it's a press fitting. Projected tolerance zone is applied to avoid assumptive interference. Only projected portion to be measured. That should be within the tolerance zone, right? Projected length is decided by the maximum thickness of counterpart. All right, let's have a quick review about this module. In this module, we have learned about TOP. We have two interpretations. Either its axis or center plane interpretation without any MMC or LMC modifier, or surface interpretation or virtual condition boundary interpretation if there's MMC and LMC. We also explain the differences between the SME and ISO GPS on the tolerance feature. SME, the tolerance feature, is the axis or center plane of AME. ISO GPS is the medium line or medium plane. We also learned what is projected tolerance zone. Thanks for watching. I will see you in the next module.